So let's talk about two critical elements that we can put in these programs that are almost always present. And we actually have both of them up here already. That's the idea that there are types of variables that you need to declare. Those variables will store information. The void here is telling us that these functions are not returning anything, but the brackets here, the parentheses, are places that you could pass in variables. You could hand information in. So one thing, variables and their declarations. Second thing, functions that you can call, giving them information, maybe getting information back. So let's look at what that would look like. Probably the most common variable type you might use is an integer, and that's got the same meaning as it would in a mathematics class. It's a variable whose values can take on integer values, so no decimal points. We'll come back to how those are stored and why this is a simulation of mathematics, but let's not do that now. You end lines in semicolons. That's how the parser knows that the next piece of information, the next piece of code is coming. To use a variable, you need to tell the code what its name is and what type it is, because there's other types of variables, floating point variables that can have decimal points, for example. So they're stored differently, and you have to tell the Arduino, this variable n represents an integer. Please allocate some storage to store that. We can then do math on n. As a matter of fact, we could do a certain bit of math right here if we wanted to, as we could, during the declaration, declare n to be some value. We don't have to, but that's probably good practice. Now we know what's stored there. Then we can do math on these. So for example, we could say down in this code, n equals n plus 3. Now, from a mathematics standpoint, that's nonsense, because n cannot mathematically equal n plus 3. But we're not doing math, we're doing an algorithm, we're doing programming. And what this statement means is take the value of n, add 3 to it, and assign it to. You can think of the equal sign as an arrow going to the left. Put the result into, in this case, back into n. So the result of this would be n equals 5. So don't get hung up on this. This looks like math. We're using a lot of mathematical symbols, but we're not actually doing math. We're doing computer programming. So the other important thing that we can do is we can call functions. So maybe we've got this variable, and we want to say, let's define another variable up here. Let's define integer k, and we'll initialize it to 0. And then we might be able to say k equals, I'll make up a function name, myfunc. And we'll hand to that function n. I was going to put a c in there, myfunc. So what this does is it's another chunk of code, which we'll write down lower in the sketch. It'll have a very similar layout. It'll tell you what kind of variable it returns. It will have a name. It will allow you to pass this variable n in, and it will do some calculations, maybe some sensing, and hand back to you a variable k. This is good for a couple reasons. It collapses your code into nice little chunks. You can reuse them. And perhaps most importantly, it allows you to use libraries of functions that other people have written that might do really complicated things, and you can just call it and get the answer.